the BLK2GO, I can't say it enough. I am absolutely amazed at this simplistic piece of technology. This is a handheld laser scanner. It is built based off SLAM technology. It is extremely user friendly. To talk a little bit about the unit itself, I'm not going to read each and every line item, but I am going to hit some high parts of each. You heard me a while ago, I mentioned SLAM. This is based off SLAM technology. SLAM stands for simultaneously localization and mapping. It's basically a combination of high-speed LiDAR, multi-camera vision system. Having these technologies is going to allow the BLK to basically self-navigate, as we start scanning. It's a very light unit. It weighs in about 1.7 pounds. The batteries and everything, they're actually built into the handle, which is a really nice feature. It's really, really, really comfortable to hold. One of the really nice features that this unit has that is a little bit different than the BLK360 is this actually does have a USB-C port for fast data transfer. So that is something that they listen to a bunch of different users say, hey, man, we'd really like to be able to use a cable instead of doing this wirelessly. So that is a big step forward. This particular handheld, it is the smallest handheld scanner. It will collect up to about 420,000 points. And the batteries, we're going to get about 45 minutes to an hour of data collection. Looking at this, just some of the key specs. Again, just going through these, we are collecting 420,000 points per second with an absolute position actually of about 3/4 of an inch indoors. So having that quality in a handheld is pretty remarkable. There are other units that get close to that, but not quite. What I like about this unit is the fact that, if I've got to go into a facility and I've got to really, really quickly capture existing conditions, and I mean, if I got to capture walls, windows, doors, floors, ceilings, that type of information, I can do it really fast. I was able to do about 4,000 square feet of scanning with this particular unit in about 3 or 4 minutes. And that was a pretty quick pace that I walked. So the data transfer, the range on this unit is about 25 meters. Of course, we know that the closer we get, the better. The data can be transferred wirelessly, or as I stated earlier, can be transferred via a USB 3.0, which is the USB-C connection. All of this data will be utilized, processed, and taken into the Leica Cyclone Register 360 software. That's where we will be working with it, completing it, getting it ready for taking into our consumable, which is CloudWorks for Revit or CloudWorks for AutoCAD or another program. A couple things I want to point out here. There are major differences between this unit and the much different traditional LiDAR BLK360. They're very similar in the simple fact that they both start with BLK. One's a handheld, one is a fixed position. You will always get a better accuracy with a fixed position LiDAR scanner. So, a lot of people go, well, they're about the same. They're completely different. So always keep that in mind. And we'll be looking at a little bit of data from both BLK 360, even the RTC data, and the BLK2GO data. So, one thing that I have to put this in here is when we start looking at which scanner is right for you, this is where IMAGINiT Technologies, we set ourselves apart from everybody else. We want to explore all the different options, all the different possibilities that we can use these scanners. All right. We may be looking at it, you may be looking at it from one point of view of, hey, I've got to scan this project. But what we want to do is try to think outside the box and expand on that, because this is not just a purchase that we're going to use one time. We want to use this thing over and over and over and over again. If this is owned, it's making us money. So what we do here at IMAGINiT is we try to look outside the box, try to help you think outside the box to get you to understand how many different areas that this unit can be used. And that's where we really enjoy helping you make the right decision on how to proceed. So when you buy the BLK2GO, with the unit, it's the BLK2GO kit. That kit includes the table stand, transport case, the charger, USB-C, straps, the batteries. You get 3 batteries. After the kit, then you typically will get the messenger bag and the CCP. CCP for Leica is their customer care package. That gets you firmware upgrades and technical support on the back end, once you have that scanner. So again, the BLK data, it flows through all traditional Leica software. Register 360, for those of you that have existing software, if you already have Cyclone Register, this BLK2GO data will go directly into the Cyclone Register software as well. So with that, what I think I'll do is I'm going to spend a few minutes looking at and working with some different data, and we're going to be doing this inside of Revit. So with that said, I'm going to come in here and go ahead and open up our Revit software. Now, a lot of the tools that I'm going to show you here in Revit are very, very, very similar to the tools that the CloudWorks software we have in AutoCAD. So if I have time, I'll touch on the AutoCAD. But right now, I want to get data into here and start showing you how to work with that data. So first things first, I'm in Revit. I'm just going to simply start a new project. I'm going to use the out-of-the-box construction template and start that project. Now, disclaimer, I'm color challenged, so I do have my background set to black. It's not because I'm madly in love with AutoCAD. I just need to be able to see that data. So now, once I've got my project set up, instead of doing the traditional insert, coming in here to point cloud and utilizing recap data, we're going to skip that step. All right. We are going to come in here and we're going to utilize CloudWorks. CloudWorks is a third-party app that Leica owns and has created. This is going to allow me to bring in traditional Leica data, whether it be, from the old IMP database, whether it's from Jetstream or the new LGS file. I'm going to choose the LGS file today just simply because it's extremely fast and handles the data very, very well. So I'm going to come up here. First things first, I'm going to hit Open LGS. Now, it is going to connect to my license. It's going to say, okay, what would you like to bring in? Today, we're going to bring in, the first thing I'm going to show you is bringing in the BLK2GO data inside of Revit. So I grab my Raleigh office, I have my UCS set, and now I bring that in, and we're off and ready to go. one of the things that a lot of people, it takes a little bit of getting used to when working with point cloud data through the CloudWorks is a lot of times we work with this data in a 3D view. So I'm just going to go to a side view, and one of the big benefits about using the CloudWorks tools is the fact that I can manage my clippings and everything inside CloudWorks without having to create a whole bunch of new views. And of course, you know, if we create new views, what happens to our model? It starts inflating in size. We want to try to prevent that because our models get big enough as it is. So what I'd like to do is, you'll notice in my view of my project browser, I have a 3D view right here. That's the view I'm in. On my CloudWorks tab, I can always come in here and utilize X, Y, and Z clippings. All right. So I could come in here, I could do various clips and say, hey, I want to clip between here and here. When I do that, I hold Shift. There is our IMAGINiT Technologies Raleigh office. This, as a kind of a rule of thumb, this is about 10,000 square feet. This was a 6-minute walk. So from the time I started to the time I finished scanning the entire area that you see, it took about 6 minutes, which is really, really pretty impressive considering if you start thinking about how fast you can walk, you know, you could cover a lot of square footage in a very, very short amount of time. So now, looking at this data, one of the things that we've always had to do is create this model. Well, one of the ways that we've done it is we just start here and start tracing. Well, I can still do that, but I would prefer not. So I'm going to go back to my 3D view, and you're going to notice that I have a clipping manager up here. On that clipping manager, once I select it, let me drag this to my screen, you're going to notice that I clip that at about that thickness. I can always come back in here and change how thick that slice is. What's really nice about that is not only can I change the thickness, I can also utilize tools to move it forward and backwards. So, you know, from an MEP standpoint, how would I use this? Oh, man, there's countless ways. You know, I'm going to come in here to my point cloud. I'm going to create a slice, and I'm going to start slicing this thing up at different elevations because, you know, looking at piping, there's piping at all different locations, you know, throughout the mechanical room. So I can utilize this clipping, move it up and down, so I can very, very quickly get that information. So just for this particular exercise, what I'm going to do is move this forward so that I can see that information. I see there's walls, all right? Well, I'm going to close out my manager, and what I'm going to do here is come back to the CloudWorks tab, because before, like I said earlier, we've had to trace things, and tracing is only as good as the person doing it. Are they having a good day, a bad day? Are they frustrated? Let's take that out of the equation, and let's start using the tools. For instance, on the CloudWorks tab, you're going to notice that I have a fitters panel, and I have wall. If I pick on wall, I can say, hey, this is what I want to use as my basis. So I could do a box, a pick point, polygon. I could select 2 points. Maybe I do select 2 points. Maybe I want it to go from level 1 up to level 2. And maybe I want to do finish face interior. This also gives me the ability to choose or allow it to be a slanted wall. I'm going to say no. So I'm going to hit OK. And I'm going to pick 2 points on that wall. All right. So when I did, you'll notice that it came up and said, hey, I found it. What type of wall do you want it to be? Let's make this particular wall a 1 inch or 1 hour partition wall. So 4 7/8. I hit OK, and it didn't work. So we'll come back. Wall. I'm going to do a polygon. We'll do wall finish face interior, and I'll just do a quick polyline around the surface of that wall. We'll come down, we'll give it which one it wants it to be, hit OK. That wall is now placed. All right, so just that easy. I'm not tracing, I'm utilizing the data that we collected. Now, there are some other really great tools in here. And what I'm going to do is I'm actually going to close out of this LGS file, and I'm going to open up another one. And we're going to open up let me grab this real quick, this mechanical or this manufacturing facility. We'll bring it in because there's another wall tool that has quickly became my absolute favorite tool. All right, and it's over here. You're going to notice that I have a quick slice tool and a polyline tool. Now, hang on. People tell me all the time, Jeff, there are no polylines in Revit. I understand that, but there is now. But it's only temporary, and it has to be removed. Let me explain. We're going to come in here. We're going to grab a quick slice, and I'm just going to say I'm going to pick 2 points. I'm going to pick 2 walls that are about 90 degrees from each other. So I pick this point, and I'll come over here and pick this side of the wall. And what that's going to do is it's going to create a very thin slice of my point cloud. All right, with me so far? Now, here's where some people go, oh, well, you know, there are no polylines, Jeff. Oh, watch. I'm going to come in here. I can do a 2-point polyline, or I can do a single point. I like doing 2-point simply because I can pick close to the points here, pick close to the points here, and you'll notice that it best fit that polyline to my points between where I pick. So I can pick there, and I'm just going to do this very quickly. Just picking these points just so we can see how all this goes together. There, here, there. All right. Now, once I do that, you'll see that line appears all the way around my point cloud. I'm going to hit escape 1 time. Now, this is where it's saying, hey, you put in this polyline, but what do you want to do with it? You know, do we want it to have a fixed shape? Do we want it to have an angular grid? What do we want to do? We're going to keep it simple. I'm going to say, you know what? Let's end the curve. When it does, it says, okay, you're going to end that curve, but Revit doesn't like polylines. So what do you want to do with this polyline? Oh, okay, well, I want to create a wall that's, you know, let's say 8-inch masonry. Now, the only hard part about this tool is deciding which direction you want that wall to go. So, in thinking about this, I've got that green line. Which way did I walk? I walked up the page, I walked clockwise. So do I want that wall to be all set toward the inside of the room or toward the outside of the room, right or left? Let's say left. So I hit left, hit OK. Just that fast, I now have those walls input into Revit. Standard tools, trim, pick, pick and pick. I've got that one. Let's add one more wall right here. If I come back, and this time I'm going to pick a single point polyline, and I'll just pick on that one wall, hit escape, end curve. I want it to go toward the right, and I want it to be 8-inch masonry. Hit OK. There it is. All I have to do, trim that together. Right there. Simple. I was able to create that room very quickly. The nice part about that is I am doing it inside of Revit. I am using Revit parts and pieces. That if we can work more efficient, we make more money. Now, let's back up a second, because one of the other things I want to show you is, let's go back to my clipping manager, and I am going to turn off that quick clip so that we see my building. And what I want to do here is, you're going to notice that I have columns. So I'm going to utilize another clipping tool called box clip, and I'm just going to highlight that column. And I'll go to a three-dimensional view so that I can, so I can see that. Let me pan over. There it is. Now, on here, again, so far I've only ever worked with the tools off of this CloudWorks tab. I now have column. I can pick on column, and it's going to automatically load your square and round columns from Revit proper. I can say, you know what, this is a rectangular column. I'm going to hit OK. And I need to pick 2 points on that rectangular column. What it does is it algorithmically extracts what that column was measured out to be. So I can do one of two things. Right here in the middle, width, depth, new type. This is what the tool found that column to be. Those are very, 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 very close to 2 foot square. Now, I could do one of two things. I could create a custom type by choosing that and going, you know what, make my Revit model exactly that size. Or you can say, you know what, I know that I am very comfortable in saying I know that's supposed to be a 24 by 24 inch column. Now, what's nice about that is it does give you an error difference between what it found and the actual standard size and shape, 1/8 inch difference. I personally am probably pretty comfortable with using that 24 by 24. But if it come up with some, 2'3" by 2'4" or I know that's probably a non-standard size column. So I probably would just use that and have it create a new size. But being that it's only an 1/8 of an inch difference, I'm probably going to go 24 square. So I hit OK. Now, if I turn off the point cloud temporary, here is my column. I will need to come in here and tell it that I want it to go from level 1 up to level 2 so that it positions itself correctly. All right. Now, I'm going to use this for another couple tools. I want to point out real quick. I'm going to hide these walls temporary. That way, I'm going to turn back on my point cloud and clear that particular clipping. Because now what I want to do is I want to be able to come in here and work with this data, create me a door. So I'm going to come in here, box clip, going to just simply do a quick clip around there, and I'm going to look at this in the view. Now, I forgot to set my levels. No big deal. We're just going to play with this just real quick right here in detail. Because the goal here is I've got the point cloud. I've got the wall. I want to take and create that door. All right. Now, I'm going to come back up here again on the CloudWorks tab. I'm going to pick door. It's going to ask me what type of door you want to put in. Now, this has a window view in it. I don't particularly have that door built, but for now, let's just say I want to put in a standard door. All right. So what I'm going to do is say, yep, this is what I want. I am going to choose fence. I just feel like I get a better selection out of it. So I'm going to hit fence. I'm going to hit OK. First thing I got to do is I got to select the Revit wall. The second thing I do is I come in and I put kind of a tight fence around my door. And it's going to say, hey, I found that door to be this dimension. All right. Now, when I do that, I can say, yes, I know what size door that is. That's going to be a 36 by 7, by 7 foot. That's going to be the closest, because the width and height of what you're looking at that it found include the frame. So I can say, I know that includes frame. I know it's a 36 by 84. I hit OK. Now, I'm going to go back and turn that point cloud back off for a minute. And you'll notice that the door's been put in. Just that easy. Same thing, same exact process for a window. I pick a window, highlight it, and it's going to allow me to put that in. So, real quick, that was very, very, very fast on how I can get the point cloud data from nothing to a pretty complete model in just a few minutes. I will tell you that when we scanned this particular room, we were able to get this entire room measured or scanned and modeled architecturally in less than 2 hours. That includes scan time. That includes processing the point cloud time. That includes bringing it into Revit utilizing these tools. So that room, that's about 4,000 square feet. So it's extremely, extremely, extremely fast. Now, the other thing I want to show you is I haven't forgot about MEP folks yet. We're going to turn this information back on. We'll grab these and we will unhide those, turn that off. The other thing that when I come in here, I turn on that point cloud. Again, I'm creating all of these clippings, but you'll notice I have yet to create any new view in my model whatsoever. So let's do this. I'll come in here and let's create a different clip this time, maybe a Y clip, and I'll clip it between here and here. That way I'm only seeing that portion of the point cloud. So just for clarity and just so we can see all of this, I'm going to get rid of these walls for right now and go back to kind of a 3D view where I can start seeing piping, all right? Because I've shown a little bit of love to the architectural folks, but I haven't done anything in the way of piping or MEP. Well, it's very, very, very simple task to create pipe. And the thing that I want to point out is, just like the walls, windows, doors, and columns, I'm doing all of this in Revit using Revit parts and pieces. To me, that's important because I'm not having to do stuff in other software and bring it in and hope that the conversion is successful. So again, on the CloudWorks tab, under pipe, on the fitters tab, under pipe, this is going to allow me to start creating pipe. Now, you do have a couple choices here. Do you want to create it with insulation? Yes or no? That means you need to know the insulation thickness. What type of pipe do I want to use? Again, this is being pulled from your MEP template. Your system type, this is pulling from your MEP template. So everybody should hear the common theme there. It's pulling from your template, what you have set up. So we're just going to go with what we have today. Again, I'm using an out-of-the-box template that has very few things set up. So I'm going to go pick point. I like that. That's my favorite. I'm going to hit OK. I'm going to pick on that piece of pipe. It's going to take it a second. It's going to say, hey, I found that to be a 4-inch piece of pipe. Great. Let's hit OK. You know what? Let's pick this one. Takes a second. It says, hey, found that one to be a 4-inch piece of pipe too. Great. There we go. All I got to do is, if all of this piping is the same, I just need to sit here and start picking on it. So, some of these pipe sizes I have loaded, some of them I don't. So I'm just utilizing what it found, the OD, to really, 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 really fast create this information. Now, I'm going to end the command, because you'll notice if I turn off the point cloud, everything is single line. Well, we know that that's because my detail level wasn't set to fine. So there's my pipe. Now, one of the biggest frustrations that everybody has is when I'm creating pipe, especially pipe, your center lines have to match up. If I go to try to trim and use the standard trim command to trim these, it's not going to work. It doesn't play well because nothing's lined up. So we have the tool here called, under the CloudWorks tab, Connect Pipe. So what I'm going to do is decide which one I want to prevent from moving. And I think my horizontal pipe here is probably the most important. So I'm going to use it first. All right. So I pick that one. I pick the vertical one and say, okay, Jeff, what do you want me to do? Well, I want you to put in an elbow. Yeah. So I check that. Now, if I do that, that's just going to put in a standard 1 radius elbow. I can say, you know what? I know that this is actually a 1.5 radius elbow. So I can actually change that radius on the fly. Here, hit OK, brings it in, places it in for me. Now, if I go back to my point cloud visibility, now I can see that my elbow lines up beautifully with that piece of pipe. I've used this data set quite a few times, so I already knew that that was a 1.5. That's just, the joy of being able to do this so much. So very quickly, I'm able to add that elbow. And you'll notice that over here, this is a food processing facility. So that elbow, that's probably more like a 6 or 7 time or 8 time elbow. So you may need to look at that, and you can use that elbow adjustment to give me something that closer fits to that. So you're not having to fight with custom families or anything. The family that it's pulling from is going to allow you to do that. So right now, I will tell you that it is just piping. They are looking at adding additional tools in the future, but right now it is just piping. So kind of recap on what we've done so far. We've talked about pipe. We've talked about columns, doors, windows, walls. Windows and doors are very, 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 very much exactly alike. And we've utilized creating, using line work to create our quick walls. So the next thing I want to show you, and one of the last things I'll show you here, from an architectural standpoint is, or not necessarily architectural, but structural is, what about us? I got all this structural, I need to recreate it. And, climbing up ladders and cherry pickers to try to measure structural steel, that can be kind of a challenge at times. So what I'm going to do is utilize our next or final point cloud data, and I'm going to bring in a structural steel building and start utilizing it. So go ahead and do that, and I have it brought in now. So real quick, I'm going to just go to a top view, and I'm going to utilize my clippings yet again. You'll notice that you're probably sitting there thinking, man, you sure do clip a lot. I absolutely clip point clouds as much as possible, especially now, because it doesn't cost me size in my point cloud or in my Revit views, my model. So it's a little bit more efficient than using the sections and elevations we've had to in the past. So I'm going to come in here. Again, I'm going to create the Z, slice through this, and maybe I'll go from here to here. All right. So I can see this structural area that I want to work with. Now, structural, it is important that we see as much of the structural element as possible. Doesn't mean I have to see the whole thing. I just need to see as much as possible. The more I have, the more complete I am able to capture. So, is everybody seeing my screen okay? We good? We good, Katana? I'll take that as a yes.
Yep, you're good.
All right. So you'll see that this is a huge structural element. There's a bunch of structural members in this particular model. I am going to go back to the CloudWorks tab. On the fitters panel, you're going to see steel. When I use this steel, we have quite a few different elements that we can create. We can create I-beams. I can create T's. I can create tubular, channel, and angle. I am going to create, just real quick on the fly, some I-beams. I'm going to use a US catalog. You'll notice that we've got pretty much every catalog you can think of. We might not have them all, but we've got the majority. I'm going to use the US, hit OK. I'm going to come in here. And first things first, I'm just going to pick 2 points on that structural member. And when I do, you're going to notice that it pops up with a dialog box. So let me explain how it's picking. First pick that I picked is it's actually cutting a section behind the scenes and looking at basically a cross section of that data in the point cloud. Okay. The second pick is the direction or how long I want that piece to go. You'll notice that in this dialog box, it says, hey, I found that to be a W12 by 26. On the left-hand side, it gives you the top flange, the bottom flange. It gives you the dimensional data on the left from the catalog. On the right, it gives you that same data compared to the point cloud. And here, stuck in the middle, it gives me a delta, the difference between the two. So it says, hey, I'm 0.02 feet difference. That's pretty good. I'm going to hit OK. And you'll notice that it brought in a Revit family and placed it right on top. That command's still active. So I just continued going through here and placing these as, oops, I picked incorrectly. Picked a little too much data there. Try that again. I-beam. Let's go, there we go. Here to here. There we go, W33, put it right in. And now I'm just sitting here, you know, the hardest thing that I have to do is make sure I pick well and look at my numbers to confirm that these are acceptable. So I'm just literally coming in here as fast as you can, looking at that, going, yep, 0.03, that's pretty good. Let's do this one. All right, let's do from here to here. Now, some of you go kind of maybe snickering, going, ha, it failed on him. Well, yeah, it did, absolutely. But here's why. All right, if I zoom in here, how much data is in and around this particular point cloud or that particular member? So from an algorithm standpoint, it's trying to grow that structural steel in all directions. It sees a lot of data behind it, so it kind of messes it up. It says, I'm not comfortable with that. So it says find something else. So it allows me to do that. But you'll notice that that's why I did small pieces. These are Revit families, folks. Yes, it renamed it to COE, so it knows. So I know which ones it put in and which ones I put in or I traced. So it does rename it just so that I know. But, you know, these are Revit parts and pieces that are being put directly into Revit. If I do structural steel one more time, and this time I'm going to do angle, I'm going to pick OK, pick. It's going to say, hey, I found that to be a 3.5 by 3.5. Well, hang on a minute. It found the length and height or length and width, but the one thing it did have trouble with is determining which thickness of L that you use. This is one scenario where, you know, if you had a better scan, it probably would do a little bit better job. But in all seriousness, all I got to do is determine which one I think it is. I could do that real quick by cutting a section through that piece and maybe measuring it. So depending on what size, you will have to pick which thickness L shape you use. Let's do 5/16. Do that, places it right in. And again, all I'm doing is pick, done. In 3 picks, I'm now just going through here as fast as I can, very accurately placing all of the structural elements. So, you know, if I turn that off, those are Revit parts and pieces. Now you can use your standard Revit tools to extend them, etc. I just did small pieces just for the sake of conversation. So, you know, that's how, and I'm not going to go through every single tool through the software, but that's going to give you the basics of what we can do utilizing the Revit tool. Now, we're going to jump back into the PowerPoint here, and bear with me a second. I need to skip ahead a little bit. So the next thing I want to point out is, you know, I've showed you all of this, and you may be going, man, that's really cool. That's exactly what we want. How do I get started? So there's a lot of different things that you can do to get started. The thing that we at IMAGINiT really want to focus on is, yeah, we want to sell you the equipment, we want to sell you the software, but what we want to do is make you successful on the back end. All right, you know, I'm about to get started. How do I get started? You come to us. We want to partner with you to ensure your success. And this is where we offer various BLK2GO Smart Starts. You know, these are 100% custom to you. What you do is going to be completely different than what somebody else may do. All right. But we bring our expertise to you, and we are going to show you everything that we can to make using this equipment very, very simple. It is a 2-day customized training. Basically, day 1 is it's going to we're going to be out in the field. You know, we want hands-on. We're going to take you, the piece of equipment. We're going to go out to a job site, and we're going to work in a whole bunch of different scenarios to, you know, because it's just when we're with you, it's going to work. It's guaranteed to work. It always works. But when we leave, you're going to start doing things. You're going to try things a little bit differently. And one of the things that we pride ourselves on is we like to try to show you during the training class just how many different scenarios there could be. And we try to put you through as many of those scenarios as we can. So typically we spend 1 full day out in the field. We're teaching you the ins and outs of the hardware and the use of the app. All right. Typically day 2, we'll get back to your office, or you can come to one of our IMAGINiT training centers, and we go through all the Leica software. All right. And again, we're going to show you the do's, the don'ts, the whys, the why nots, because we feel like if we can show you all of this up front, you're going to minimize your learning curve. You're going to be more proficient starting out right out of the gate than having to go, how do I do that? So we really, really want to hold your hand the first 2 days. And that's not to say that it's just going to be 2 days. We could say, hey, look, you know, we may need to extend a day if we're having troubles or you know, you have a lot of people and we want to do a lot of training. These are 100% customizable trainings. We customize these day in and day out. So with that, do we have any questions? We'll go ahead and wrap up with that. I'll turn it back over to you, Katana.
Thank you. We do have a few questions.
Okay, great.
Let's see. Does this interface with Matterport?
The BLK2GO right now does not. The BLK360 will. That's a good question.
Could you go into what the difference in accuracy is from the 360 to the BLK2GO?
Sure. So with the BLK2GO, I'm going to abbreviate it. I'm going to say to go or 360. That's my two scanners. The 360 has an accuracy of 6 millimeter at 10 meter. That's measured from basically the center line of unit out 10 meters. That's the point accuracy that we're getting. The mobile or the BLK2GO, it's a lot different. So it's measured a lot different, but at approximately a fixed distance, we're about 3/4 of an inch. So, but again, we have to remember, one is traditional fixed, one is walking, it's mobile. So the fact that we're getting a 3/4 inch walking around, that's very, 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 very pleasing to me. I am very happy with that. So if you need accuracy, if you have to have a 1/4 inch or 1/8 inch or even 1/16 inch accuracy, then you need to not look at the BLK2GO. You need to look at a traditional fixed LiDAR scanner. All right. And I'll say this and we'll move on. What's your end goal? Do you want it pretty accurate, somewhat accurate data, really, 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 really fast? Or do you want really accurate data that takes a little bit more time? If all I got to do is go in and get walls, windows, and doors and general layout stuff, and 3/4 of an inch accuracy is all that you'll ever need, then I would tell you, you probably want to use the BLK2GO. But from an MEP standpoint, I would tell you, yeah, if you want to be able to extract the piping and things like that, you probably need to go with the more traditional fix, because I need to be a little bit more accurate to extract that geometry. So hopefully that explained it.
Yes. Next question. Does this unit require yearly calibration like traditional scanners?
It should, absolutely.
Next one. How much is the Cyclone software? So how much would it cost to complete the system? So software and unit.
So hardware, the BLK2GO, hardware, software, and training, you're looking at about 75. And that's a little bit, I rounded up. It's a little less than 75,000.
Okay. Next questions. Do you have all of those wall types already in the project before generating your walls?
Those wall types would be in your template. So whatever you have loaded in your template, that's what you will be able to pull from.
And is that the same for the W shapes for the columns?
It's a little different. The W shapes will actually go out to the Revit catalog, find what it needs, and bring that one piece in. It doesn't bring in all of the W shapes known to man into your project. So it doesn't fill up your project. It's just simply going out going, hey, there's a W shape, grabs the one it needs, puts it into your project. The wall types, those are system families, so you have to have those built in your template. If you don't have those built, then you're able to choose just a generic wall type. Good question.
Do the selected families need to be parametric in order to auto size?
They do. Absolutely.
Is this CloudWorks for AutoCAD or is there CloudWorks for Revit?
So I showed CloudWorks for Revit today, but the CloudWorks for AutoCAD is very, very, very similar. It's built more around the 2D layout. So the polyline tool that I showed, where I pick 2 points or pick single point, that is the exact same tool in AutoCAD. The structural steel is in AutoCAD as well. The piping tool is in AutoCAD as well. And I'm able to very, very quickly create 2D plans utilizing those tools. Not to go too deep, but to add to that, if we have any Plant 3D users out there, when I utilize CloudWorks for AutoCAD, because Plant 3D or Civil 3D, both built on AutoCAD platforms, I can extract pipe from the point cloud and convert those to Plant 3D parts and pieces in AutoCAD. So they would become, I would show the center line. I would convert the center line using the line to pipe tool in Plant 3D. Those would then become intelligent 3D pipes.
Next question. Does this structural dialog require the default family locations to be pointed to the default local drive location?
They do, but that's not to say that we can't tweak that. I'll leave it at that.
Okay. Were the data sets used in the Revit demos BLK2GO or other static scanners?
They were all three. The BLK2GO. The first data set was the BLK2GO, where I created walls. The second data set where I created the additional walls, the columns, the doors, that was actually RTC data. And the last structural, that was collected with a BLK 360. So I wanted to try to show a little bit of each.
CloudWorks for AutoCAD and CloudWorks for Revit, is there a difference in price for the license?
They are the same price. There's actually, not to go too deep, but there are actually three different choices that we could do. You could do CloudWorks for AutoCAD as a standalone. You could do CloudWorks for Revit as a standalone. Or if you are a multi-software shop where maybe you're architects or MEP firm that uses both AutoCAD and Revit, they do have what they call a CloudWorks Ultimate. It is one license, but it installs all the CloudWorks for the Autodesk software. So there's CloudWorks for AutoCAD, CloudWorks for Navisworks, CloudWorks for Revit. That Ultimate will install all three and let you use one at a time for one license. So you really get the benefit of all three CloudWorks with one license. It's a little bit more expensive, but instead of buying one each, you get one and it takes care of all three.
Okay. I know you covered this, but 3/4 of an inch over what range?
It's measured a little bit different. It's 3/4 inch within about 10 or 15 feet, 20 feet. That's a ballpark. Because like I said, the accuracy is measured a little bit different. And it'd take me a little while to explain that one. But if you would like, reach out to me afterwards and we can have that conversation.
Okay, wonderful. That is it for the questions. There's a couple that we will answer offline, and we'll send you emails. This was being recorded, and we'll make sure that everyone gets a copy. And thank you so much, Jeff.
Thank you.